This lesson is an introduction to rational expressions. First of all, we want to define a rational expression. A rational expression is an expression that can be written as P over Q, where P and Q are polynomials. A rational expression is defined whenever Q is not equal to 0, or whenever the denominator is not equal to 0. So we're going to be working with rational expressions for this entire chapter. Right now we want to just evaluate expressions, and we evaluate by substituting in the value they give us for the variable and finding the value of that expression. So we'll substitute a 2 in for every place we see a y. So it'll be a -2 plus 1 all over -2. We want to make sure that we're squaring that entire y, so we have to put it in parentheses. It makes a big difference. -2 plus 1 is -1, and -2 squared is the same as -2 times -2, which is a +4. So we get a value for that expression of -1/4 when y equals -2. And if we want to evaluate this, again, we'll put z as a -2. So 7 times -2 all over -2. We want to square that entire z minus 4. So this is a -14 over 4 minus 4. So -14 over 0. Okay. Up in our definition, it said that a rational expression is defined whenever the denominator is not 0. We have put in a value for z that makes the denominator 0. That means that this expression is undefined. You'll see that as well when you put that into your calculator. If you were to put in a -14 divided by 0, you get an error, and it says the error is that you divided by 0. All right. So apparently there are some times when we cannot use certain values for the variable in an expression. And that's a drive for a lot of the things we're going to do in the next few sections. So we want to learn how to determine when a rational expression is undefined. A rational expression is undefined when the denominator equals 0. We don't want the denominator to equal 0, or it will be an undefined expression. Here we're going to find any values of the variable that make the expression undefined. Here the denominator is x. And we know that we don't want the denominator to be a 0, so we're finding the values that make the expression undefined. X equals 0 would make the expression undefined. Okay, so that was not so bad. Let's try this one. We're looking at the denominator again, and we know that the denominator equaling 0 would make that expression undefined. So we can figure out what it is that makes it undefined. And apparently when z is 7, it makes this expression undefined. What makes the expression undefined? When the denominator is 0. So z equals 7 makes the expression undefined. We're looking again at the denominator. The denominator is going to determine whether an expression is defined or undefined. So we're looking at this denominator, and we know that t squared plus 1 equals 0 would make that expression undefined. So just like in the problem before where we set that denominator equal to 0 and solved it so we could find the value of the variable that made the expression undefined, we're going to try to solve this. Now this is a quadratic, and we learned in the last section that to solve a quadratic, we have to use the principle of zero products. So first of all, we can't do anything with this because this is not factorable. We do have a 0 on one side, but we cannot factor this. Okay? Remember that a sum of squares is prime. You cannot factor it. So we're kind of stuck. There's nothing that we could do with this. That means nothing makes it undefined. All right, so if we look at this, let's say that we let t equal 0. If we let t equal 0, 0 squared is 0 plus 1 is 1. So a t value of 0 makes the denominator 1. That's not undefined. Let's say if we tried something like putting a negative 1 in there. A negative 1 squared plus 1 is 1 plus 1, which is 2. That's not 0. So apparently, a negative 1 is not a problem either. It's okay to let t equal negative 1 here. Same with 1. If I put a 1 in there and squared it, I would get 1 plus 1 is 2. Does not make that expression undefined. In fact, there's nothing that we can do to make this expression undefined. If I put a negative in here and square that negative, it makes it positive. And if I add 1, it only makes it a larger positive number. If I put in 0 and square it, it's 0. And I add 1, it makes it a positive number. If I put a positive number in here and square it, and then add 1, it makes it a larger positive number. So there's nothing in this expression that we could do to make it undefined. What about this expression? It's not so easy to look at a problem like this and be able to pick out right away what makes the expression undefined. But the definition of being undefined is that the denominator, so we'll go ahead and write out what the denominator is. If that denominator equals 0, then that makes the expression undefined. So we're going to try and factor this. Remember from the last section, we have to factor this because it's a quadratic, and so we're using the zero product principle. We have a 0 already. We're going to make a product out of this by factoring. So I'm going to break up the 2z squared as 2z and z. And let's say that we do a 5 and a 1 there. They have to both be negative for us to get a positive there and a negative there. So check the middle term. Negative 2z and negative 5z is negative 7z. Now we're going to set each expression equal to 0 and solve those. Okay, so apparently we have two answers here. This one and this one. A value for z of 5/2 or 1 makes the expression undefined. Now what about the numerator? You may be looking at that numerator and saying, gosh, isn't there something we could put in there that makes that undefined? But remember what the definition says. The definition says that a rational expression is defined whenever q, the denominator, is not equal to 0. So it has nothing to do with the numerator, has everything to do with the denominator in a rational expression. Now we're going to learn how to simplify rational expressions. Even after we learn this, it'll be your responsibility to simplify rational expressions in every section after this. In the first chapter, and reviewing, they use basic principles of fractions, which if I have a numerator of a times c and a denominator of b times c, then you may have seen this before where they cancel out the c's and it makes it an a over b. That's simplifying. What makes us have the right to do that? Well, a times c over b times c would be the same as if I had a over b times c over c. And what is c over c? C over c, c divided by c, is 1. So I have an AB times 1, which is A over B. There we go. So it's called removing a factor of 1, and this just happens to be a factor of 1 that looks like C over C. We're going to use that same principle to simplify the rational expressions with polynomials. The following property can be used to simplify rational expressions where P, Q, and R are polynomials. Okay, so these are just like the numbers were, except now they're polynomials. Still, it's being multiplied. They're canceling out the r's because it's that factor of 1, and we get P over Q. And Q and R are non-zero just because they're in the denominator, and we know that we don't want zeros in their denominators. So we're going to simplify. First, we're going to simplify some fractions, and then we're going to simplify some rational expressions and kind of look at the similarity between those. Here we have 8 over 16. Now, I'm sure that you probably know that 8 divided by 16 is 1/2. If you're not sure of that, then we can always factor and see that. But I want you to do this the long way, just so you can see how doing it the long way is the same way we would do a rational expression. So here, I'm looking at 8 and 16, and I think, well, 8 goes into both of those. So 8 is 8 times 1, and 16 is 8 times 2. And here, I have that common factor of 1. I'm able to get rid of that. It makes it a 1/2. Now, what gives you the right to be able to cancel those? It's because we have these multiplied right here. Okay? And I'll show you in a minute why you have to be very careful when you are simplifying fractions and rational expressions this way. Here, we have an x plus 2 over a 2x plus 4. Now what you cannot do is you cannot cancel those x's. You can't cancel these 2's or cancel this 2 into this 4 because, and write this down, you cannot cancel terms. Now terms are things that are added and subtracted from each other. Since these things are being added and subtracted from each other, we cannot cancel them. You can only cancel factors. Okay. Now right now I don't see any factors here because it's not factored. So that's my first task, is to factor it and see if I might be able to cancel some of those factors. Let's look at the top here. X plus 2 can't be factored. The denominator is 2x plus 4. We can take a 2 out of that, and that gives me an x plus 2. Okay? And now you can see, if it helps you to put parentheses around this, then go ahead and do that. We have a factor of x plus 2 on top, a factor of x plus 2 on the bottom, and we're going to cancel those, removing a factor of 1. And what do I have left? Well, first of all, I have a 1 on top, and I have a 2 on the bottom. So it gives me a 1/2. You can see how it's similar to the canceling over here. Now let me show you what you don't want to do. Okay? And if you write this out, make sure that you put the title that this is bad math. Okay? This is why you cannot cancel terms. Let's say if I have something like 2/4, okay? And I want to simplify 2/4. Now, in your head, you should be thinking, okay, I know that that's a 1/2. So we're going to go ahead and try and simplify this. Now, just kind of follow along with me. Now, remember, this is bad math, so it's not the right way to do something, but it's going to illuminate to you why you cannot cancel terms in rational expressions. Let's say that I want to break that 2 up as a 1 plus 1. And I want to break the 4 up as a 1 plus 3. Okay? 2 is 1 plus 1, and 4 is 1 plus 3. I see, oh, I have a common factor. I'm going to cancel that out. And so now, all of a sudden, magically, 2/4 is 1/3. Now you can imagine how useful this is when you're baking a cake. You need a half a cup of sugar and you don't quite have it, so you can just simplify that fraction and make it 1/3, right? Now, that is silly. It doesn't make sense. So in the same way, we could not cancel something like this. Let's say we had an example like 2x plus 4 over x plus 2. Very similar to the last rational expression we worked on. And let's cancel what we can. Let's see, 2 goes into 4 2 times, and the x cancels and the x cancels, and I add those together. And what do I get? I get a 4 over 0? That doesn't make sense, does it? So both of these are bad math. It's a big no-no to cancel terms. You do not ever cancel things that are added and subtracted. You can only cancel things that are factored. So you factor first. That's why one of the reasons that factoring is so important. You factor first, and then you can cancel the factors, but never the terms. Let's go ahead and simplify something like this. Okay, 7 minus 3 over 3 minus 7. We could probably go ahead and simplify this, right? 7 minus 3 is 4 over 3 minus 7 is negative 4. And I see the common factor there of 4, and that gives me a negative 1. Let's try and simplify this one. 7 minus x over x minus 7. Now those are completely different expressions. Okay, think about if x had a value of 2, then 7 minus 2 would be 5, and 2 minus 7 would be negative 5. So those are completely different numbers, just being rearranged that way. So it looks like, maybe we can't do anything here. But there's actually a little trick that I need you to learn, and we're going to factor out a negative 1. Okay, we're going to factor out a negative 1, and you'll see what happens here. If I factor out a negative 1 on the numerator, I get a negative 1 times negative 7 plus x, and the denominator is still x minus 7. Now, can't I rearrange these numbers as long as I keep the sign in front of the number? Of course I can. So this is negative 1 times x minus 7. That's all over x minus 7. And we can cancel those x minus 7's. Why? Because this is all being multiplied. And if it helps you to see that this is a factor, then go ahead and put parentheses around that too. And you can even make this a 1 times that. It doesn't change anything. After we cancel those x minus 7's, we have a negative 1 divided by 1, which is negative 1. So it cancels in a similar way. We end up with the same type of number. We'll end up using this a lot, and these are what are called opposites. Okay, so opposites are things like x minus 3 and 3 minus x. Okay, 4 minus 5x and 5x minus 4. Okay. Now something like x plus 2 and x minus 2 are not opposites. It has to be that both numbers in that expression have opposite signs. So this x is a positive here, over here it's a negative. This 3 is a negative, and over here it's a positive. Same with this, a positive 4, but this one's a negative 4. A negative 5x and a positive 5x. So if we were to simplify something like this, so if we want to simplify 4 minus 5x over 5x minus 4, then we end up with something very similar to this. Let's factor out a negative 1 here, and I'll go ahead and rearrange. Negative 5x divided by negative 1 is a positive 5x, and a 4 divided by negative 1 is a negative 4. and the denominator is 5x minus 4. Again, we're right where we want to be. We can cancel those factors, and we get a negative 1. So we get a little bit of a shortcut here. If you realize you are dividing opposites, it's always going to cancel out to be negative 1. So we can use that to kind of speed things up in the next few sections when we see opposites that are simplifying this way. We're going to simplify this expression now. What I would like you to do is go ahead and factor, because we want to remove a factor of 1. Now, how would we factor? We're going to factor out the greatest common factor between those. What is the greatest common factor between 6 and 8? The greatest common factor is going to be a 2. The greatest common factor between x and x squared is an x. And the greatest common factor between y cubed and y squared is y squared. After I factor out a 2x squared from the top, then I get 4y. Now look at that. If I would multiply everything back, you would get that same expression on the top. And on the denominator, I'm going to divide out the same thing that I did on top. So 6 divided by 2 is 3. X squared divided by x is x. Y squared divided by y is 1. All right, now do you see that common factor? We have 2xy squared and 2xy squared. We can cancel both of those out, and this expression simplifies to be 4y over 3x. We're going to do a similar thing here. Remember, we always have to factor. You want to cancel factors, not terms. So what we'll do is factor the numerator. Let's see, that factors as 3 times z minus 3. And the denominator factors as 5 times z minus 3. Okay, now it's really easy to see that common factor of z minus 3. This simplifies as 3/5. But you cannot cancel by canceling this way and canceling those z's. You can only cancel things that are being multiplied. This is 3 times all of that and 5 times all of that. So we're going to cancel those factors. Let's see if we can do something with this one. The numerator, I see, we can factor out a greatest common factor of 3, and we're left with x plus 7. And the denominator, I might probably try to factor out a negative 1. And that would give me a 7 plus x. Now, isn't 7 plus x the exact same as x plus 7? Just the order is switched around. So I can cancel those factors, and I'm left with 3 divided by negative 1 is negative 3. On this problem, I want to first start off by factoring. So the numerator, I'm going to take out an n, and I'm left with n minus 1. And on the denominator, I see a greatest common factor of n as well. So I'll factor out the n and have n minus 5. Now we can see a greatest common factor of n. It's not always the thing that's in the parentheses that you're going to cancel. It doesn't matter if it's in parentheses or if it's a single factor sitting out front. Those are still multiplying the n minus 1 and the n minus 5, so we can cancel those. And then we're left with n minus 1 on the top and n minus 5 on the bottom. Let's try this one. Looks like we're going to have to factor a couple of trinomials, so let's get started. Get a couple of parentheses down. We'll break up the 2x squared as 2x and x. And the 4, I'm going to break up as 1 and 4. I'm going to try a plus here and a minus here to get my negative 4, and let's check the middle term. That's an 8x minus 1x is 7x. So that's factored for us. And let's factor the denominator. 6x squared. Let's try breaking up 6x squared as 2x and 3x. And try breaking up the negative 2 as 1 and 2. And let's see, let's try and make this a plus and this a minus. So that gives us our negative 2 there. Check the middle. So 4x minus 3x is 1x. So we have a 2x minus 1 that we can cancel, removing that factor of 1. And we're left with x plus 4 over 3x plus 2. Now, can I cancel the 4 and the 2? No, because this is attached to the x by addition. This is attached to 3x by addition. They are terms. We cannot cancel terms. We can only cancel factors. And that's it for this lesson. You should be able to do that section's homework. Feel free to email me if you have any questions.